Dear student, you are warmly welcome to this program of Elimika, Form 5 Geography. And today we have been blessed to see it's a very glittering day. We have been discussing about the topic of the dynamic earth and the consequence. And so far so good, we have covered a lot that we have been able to see what is happening when we speak about plate tectonic, what happens when we speak about isostasy, what happens when we speak about continental drift, and what happens when we speak about the materials of the earth. Now, in those few parts that we have gone through in geography, remember that our first part, when we started the topic of the dynamic earth and consequence, was isostasy theory. Okay. But we discussed about what happens within the Earth's surface, that up to the moment we have highlands, we have hills. But one of the effects of the isostasy theory, we said that the theory actually, because of the movement within the Earth's crust, that there is the occurrence of earthquake. Okay? And again, when we went to the theory of continental drift, at last, because of crustal deformation, we spoke that there also occurs numerous earthquakes in different plate margins. And again, when we discussed about the plate tectonic, we said that this is the main issue on the Earth's surface when plates move away from one another, towards one another, sliding past one another, or sometimes colliding. So the main effect that people can speak about on the Earth's surface resulting from the plate tectonic was the earthquakes. That the earthquakes are very numerous on the Earth's surface. The earthquakes make the impacts on the Earth's surface. Some people die, some people lose property. We get some houses being cracked down and so forth. So today, my dear students, we need to discuss about earthquake. Why have we been saying that isostasy leads to earthquake, continental drift leads to earthquake, and plate tectonic leads to earthquake? Why all this? Now today, you are warmly welcome that we need to discuss about the impact of earthquake. So as regards the series of the topic, the impact of the earthquake, this is part 4. Part 1 was isostasy, part 2, continental drift and plate tectonic, part 3, materials of the earth, and now we go to the impact of earthquake. My dear Form 5 student, you are not new to this natural calamity, sometimes being accelerated by humans' activities. And I know you can all define the meaning of earthquakes. Okay, so if I were to ask the meaning of earthquakes, you student of Form 5, you can be able to describe. Because even in Tanzania, some years past, we had the earthquake event taking place, making Kagera region as part of the epicenter. Okay, that was in September 10th, I think 2016. And therefore, I know you were born by that time. You heard a lot about the earthquake. You can tell a lot about the impact of earthquake in reference to what's happening in many countries. Forget about Tanzania. That the Philippines have been crying because of earthquake. The Japanese have been crying because of earthquake. And many countries, to include Mexico. Okay. And therefore, that's why when we speak about the dynamic Earth, we speak about what's happening inside the Earth and what we can feel on the Earth's surface. One of the feelings that we witness on the Earth's surface resulting from the dynamic Earth is the earthquake. So what is the earthquake if one were to ask for the definition of earthquake? So we are saying earthquakes are sudden movements. There are sudden movements or vibrations in the Earth's crust. Yeah, in the Earth's crust. And that's why some other scholars of thought are referring to earthquakes as merely natural tremor. That we have the shaking, we have the vibration on the Earth's surface, and therefore this becomes so clumsy to people living on the Earth's surface, animals and other properties, that because we have the movement inside the Earth's surface, and therefore the top part of the Earth's surface becomes shaky, that everything is at shock-sturvy on the Earth's surface. And that's why we are saying that merely earthquakes refers to sudden movements of vibration the Earth's surface. Okay, in other ways, it is a series of vibrations. It is a series of vibrations. A series of vibrations or seismic waves. Or seismic waves that originate from the focus. Originate from the focus. So later on, we will discuss about the focus, the origin of the earthquake that is far deep the Earth's surface, that where the shock waves start from, where the vibrations originate from inside the Earth. This we are going to discuss, that this point is known as the focus. So we are saying that the vibration of the Earth's crust, the vibrations of the Earth's crust result into violent shaking. Result into violent shaking, and in turn causes great destruction. Okay, so now imagine that we are living on the Earth's surface. What happens if the Earth's surface is shaking? Because of what happens in the Earth's surface. Imagine that, take an example, that this is the Earth's surface, okay? And we are living on the Earth's surface. We have houses on the Earth's surface. We have plants on the Earth's surface. And people and animals are working here. Okay, now if this area becomes shaky because of the seismic waves that is generated inside, what happens to us? It means, that's why we are saying that the vibrations lead to great distractions on the Earth's surface. Now, my question is, what is being distracted by these vibrations? You can imagine that you have your home here, okay? You are inside your home, and your home is in touch with the surface. Now, if the surface is shaking, it means this will lead to the destruction of your homestead, the destruction of what you have as your human property. Sometimes this can rise up, can be overturned up and down, leading to severe impacts, resulting to death. So, we are saying that in order to have something we call earthquake, we have the point of origin, okay? And therefore here, it's good to make things clear that in order to have earthquake, we can't abandon the two words, focus and epicenter. Focus and epicenter, okay? So imagine that we consider this as the origin of earthquake, inside the Earth's surface. Okay, this is the point of origin where now the seismic waves start to flow, and this is found within the Earth's surface. And therefore, the point on the Earth's surface where the first shock occurs, immediate point that is vertically above the focus, this is what we call epicenter. Now here, let's assume that we have, this is inside the Earth's surface. This is inside the Earth's surface. And now here, this is the point where now the seismic waves, the shock originate from. Now this becomes the focus. The focus. Now, the point above the focus on the Earth's surface, where the shock starts to hit the surface, this is what is called the epicenter. The epicenter. And therefore, we are saying that the point at which an earthquake originates is called focus. Is called focus. As you can see here, is called focus. And this one, it is several kilometers. A point several kilometers. Several kilometers below the surface. Below the surface. But the epicenter now, the point on the Earth's surface, immediately above the focus. Above the focus. My dear student, get these terms clear, that when you are trying to conceptualize the term earthquake, you cannot abandon to mention what we call the focus. That the vibrations, these natural tremors, originate from inside the Earth's surface. Now that point where now the seismic impulses, the seismic waves originate inside the Earth, this is the focus. But the point on the Earth's surface where now the shock first hits the surface, this is known as the epicenter. Therefore, in good terms, when you are speaking about the earthquake, these are the sudden movements that originate from the part inside the Earth called focus. And again, the impact is going to be made on the surface at a point known as epicenter. From there now, the seismic waves, they will start scattering to different directions, leading to different impacts. Okay? And therefore, we are speaking about the earthquake. The earthquake that is caused by what is called seismic waves. What are seismic waves? Merely, this is energy that is generated. And therefore here, we speak about earthquake waves or seismic waves. Seismic waves. What are seismic waves and what are the earthquake waves? This is one thing, okay? Therefore, the seismic waves that we have been speaking about in our key definitions, what do they mean? Seismic waves, these are energy that travels through the Earth's layers. Energy that travels through the Earth's layers. Okay? This is not something new when we speak about the Earth's layers. We saw this in our first topic, that the Earth internally is in layers, that we have the lithosphere, the mesosphere, and the core. So these ones are what result into earthquake. Into earthquakes, and therefore, not only do they result into earthquake, movement of magma, volcanic eruptions, and so many things that make the Earth qualify that really the Earth is dynamic. So from now you need to understand that when we speak about Earth dynamism, we are referring to the movements that are taking place within, that inside the Earth is ever at havoc, that it is not static, there are movements, volcanic eruptions, magma moving from one side. Places are moving also, leading to what we are now discussing today as one of the impact of the Earth dynamic state is the earthquake. Okay, now this energy, these seismic waves may also lead to landslides. Okay, this is we can go to discuss. We are going to discuss this when we are discussing about mass wasting. Now, what are the types of seismic waves? These waves that are really disturbing us on the Earth's surface, and they are having their origin internally, but the impact we face on the Earth's surface. So, what are the types of these seismic waves? Okay, here we are going to discuss about the types. So one is body waves. Body waves. These travel within the Earth's interior. The Earth's interior. Okay? These actually are traveling within the Earth's interior, that they don't strike the surface, and they are categorized in two main parts, that we have primary waves and we have the secondary waves here. So here, when we speak about P waves, this is one of the first category that we call body waves, and these ones now, these are faster enough to have a short wave length, faster enough to have a short wave length, with average velocity of 8 kilometers per second. Okay, and therefore we are saying that these primary waves are very powerful, that they can travel through both solid and liquid materials. Okay, that they can confront all liquid and solid materials, and therefore they can work within magma, and they can also work within the solid materials, within the Earth's surface. And sometimes they can arrive at a point of 11,000 kilometers from the epicenter. Nearly for about 14 minutes. Imagine such a speed. That now, these body waves are very strong. They are very fast. That for them, they can move for about 11,000 kilometers within 14 minutes. So imagine if the warning is not given, if these geologists do not give information area enough, so many people may likely to get infected, to get affected, to get damaged by this earthquake because of the P waves that are very strong, very fast, and so forth. And the second that we have here are secondary waves. The second type of a body wave is S waves. S waves. The secondary waves, these are propagated at right angles, and cause cluster rocks to move side by side. And cause cluster rocks to move side by side. So imagine that now even the rocks we discussed, the cluster rocks, are now moving side by side to different directions because of these secondary waves. So my dear student, when we speak about earthquake, we speak about what is being generated by the seismic wave. Okay? That originally they emanate from the center, from the focus, the point within the Earth's surface. But the impact is going to be made on the epicenter now. That when now you have the shaking, sometimes life becomes so hard that the houses are dismantled, the dams are broken down, the water pipes are also bursting, gas pipes are also bursting, and therefore the shaking of the Earth's surface makes everything not in harmony, that everyone is trying to run out so that he or she can save his life. And the last one, the last type, the second type of a seismic wave is the surface waves. Okay? So we have surface waves. We had the body waves. Now, secondly, we have the surface waves. Okay, so these surface waves travel through the surface rocks. These travel through the surface rocks. The surface rocks of the Earth's crust. And we are saying that they are alternatively called long waves. Alternatively called long waves. Okay? Long waves are following the fact that they have long wavelength. That because they have long wavelength, that's why they are called long waves. And therefore, my dear student, from now on, you need to understand that what people have been speaking about as earthquake, this is actually the vibration of the Earth's surface, the sudden shake of the Earth's surface that may lead to different impacts to all living and also to non-living things. That you have your house is getting shaken sometimes, breaking into, you have the Earth's surface being overturned, and therefore the main reason, the main source of these are seismic waves that originate from the focus, okay, and then the impact is first felt on the surface, especially at the epicenter. My dear student, having seen the concept of earthquake and what happens inside the Earth's surface, that from the focus, then epicenter. Now let's see what really causes the earthquake. Causes of earthquakes. Okay, geography as a series of events. You remember when we were discussing about the plates movement, that we have the movement of plates on the Earth's surface. some of these being continental plates and oceanic plates. Now, that as the plates move, they either move away from each other, towards each other, or past each other. That sometimes they even collide. Now, in this sort of movement, they generate also pressure that an energy that may result into earthquake. And therefore, the main causes of earthquake here are two, that we speak about the movement of plates and volcanology. So here we have earthquakes are mainly caused by one, plate movement, and volcanic eruptions. On the plate movement, we are saying that plates may move away from one another, towards one another. They can slide past one another. And sometimes they can collide. So here, stress and pressure build up. Stress and pressure build up as plates try to move. Here, we get sudden release. Sudden release of pressure when the plates break free. When the plates break free along the fault line. So here, because of plate movements, we speak about what happens on the plate margin, on the boundary, on the demarcations of these plates. That now, when they move away from each other, they create what is called divergent plate margin. And this, as we said, it leads to the formation of different features, including the rift valleys. And it's only on these margins that most likely the impact of earthquake is likely to be bigger. When they move towards each other, they create what is called convergent plate boundary. And now, as they move, they squeeze each other. If it is continental and oceanic plate, we get the oceanic plate subsiding over the continental plate, creating what is the subduction zone, volcanic arcs, and some other things. But now, when they slide past one another, what happens because of the energy as they bypass, they lead to the formation of faults and earthquakes. And therefore, that's why we are saying that the main cause of earthquakes on the Earth's surface, the movement of plates and the volcanic eruptions. Here, we are saying that huge amount of energy is released. Huge amount of energy is released, and the shock waves or vibrations. Shock waves or vibrations travel through the earth as an earthquake. As an earthquake. So it means because of the plate movements now, huge amount of energy is released, okay? And the shock waves or vibrations now will travel and they strike the Earth's surface, leading to earthquake. The second being volcanic eruption. Volcanic eruptions. These involve the movement of magma. Movement of magma through fault line. Through fault line. The movement of molten material here molten materials here causes sudden release. Sudden release of stress to cause vibrations. To cause vibrations on the Earth's surface. On the Earth's surface. And actually the vibrations here is so-called earthquake. So, my dear student, these are the main two reasons, the main two causes of earthquake. That when we have the plates moving either away from one another, towards each other, or past one another, or even colliding, there is energy that's always generated, and therefore this leads to vibration and shaking of the Earth's surface, and that is the earthquake. The same as when we have the movement of molten material inside the Earth, that is magma, now they will cause also sudden release of stress that will turn into vibrations of the Earth's surface, and that is the earthquake. There are other minor causes. Minor causes of earthquake also. Minor causes of earthquake here. That we have human activities can also lead. Human activities, e.g. mining, using sophisticated machines. These can also lead to vibrations of the Earth's surface. Falling of heavy objects like meteorites. Like meteorites. Also, mass wasting like landslide and lockfalls. Landslide and lockfalls. Lockfalls, plus movement of animals in a huge number. Here, animals can be wild animals, or even the animals that are kept by human beings. When you have a large flock of cows, we can speak about maybe when we have these big animals found in the game reserves and so forth, that as they operate, as they move daily, they can lead to the shaking. But that's why we are saying these are the minor causes. And the very main causes are two, the plate movement and the volcanic eruptions. Now, how do we measure earthquake? Measurement of earthquake or assessment of earthquake. Here, earthquake is measured by detecting seismic waves. by detecting seismic waves. Seismic waves. Using an instrument called seismometer. Seismometer. Some are calling this seismography. Seismography. Okay? So mainly, we need to detect the seismic waves. That's what we can do when we are assessing the intensity, the magnitude of the earthquake. That mainly we use seismometer, also known as seismography, to determine the intensity of the earthquake that's most likely to occur at a certain place. My dear student, now we're on this part of measurement of the earthquake. We are saying that the earthquake is measured by detecting instruments. Mainly here we have seismometer. Seismometer or seismography. That here now, the impact of earthquake will depend on the intensity and magnitude. So actually, these instruments actually are measuring or detecting the earthquake's intensity and magnitude. Now, what do we mean by magnitude? We say this is the magnitude of an earthquake. So magnitude of an earthquake is the total amount of energy released during this issue. The scale which gives the magnitude is called Richter scale. The intensity, what we mean by intensity here, intensity of an earthquake here refers to the effects produced by the earthquake. Mainly measured on Mercalli scale. Sometimes there are maps that are produced showing the areas that experience the earthquake in the world. Sometimes you can find the lines that are joining different places that are facing the same magnitude, the same intensity of earthquake. And the lines that are drawn on the map are known as isocms. These are the lines that are drawn on the map to connect places with the same strength of shaking. Now, my dear students, having seen now the meaning of earthquake, what causes the earthquake, what is instruments are used to assess the earthquake. Now, I can ask you a question. What are the disasters, the hazards caused by earthquake? One may likely say earthquakes lead to death of people, destruction of properties, and so forth. But those are not the only impacts of the earthquake, the only hazards that are caused by earthquake. Okay, disasters or hazards caused by earthquake. Some still recall on what happened in Kagera region, that more than 16 people lost their lives, people lost their houses and so forth. So one is damage to buildings. Damage to buildings, structures, and transport systems. Here, because of earthquakes, we get the buildings, very heavy buildings collapsing. We get structures collapsing like railway lines, roads, and so forth. Water systems are also dismantled because what shakes is the surface. And whatever is on the surface is also undergoing the same impact, and that's why we are saying that one of the impact caused by the earthquake, the disaster caused by the earthquake, is damage of buildings, structures, and transport systems. The second being injuries and death. Injuries and death. So areas like the Philippines, Japan, that have been confronted by this. Tanzania in 2016 also had this, where many people were injured and some deaths happened there. We get surface displacement. Surface displacement generally along fault lines. Along the fault lines. And this may lead to the fracture of pipes, gas pipes, as well as causing damage to lines of communication, as well as causing damage to communication lines. And the other one, we have geomorphological hazards. Like landslides, liquefaction, and tsunami. This is the wave that passes via the ocean floor. And sometimes floods from collapsed dams. Because of the shaking, the dams also are collapsing, therefore water overflows. Release of hazardous materials. Here get ashes, gases, and so forth. And sometimes it can lead to spread of chronic illness. That when we have the ashes being blown up, when we have dust into the atmosphere, sometimes they can cause some chronic illness to people. And therefore, having seen that, we have the factors affecting earthquake damage. These are the damages. Now we have the control factors that may control this, that the factors that are affecting the earthquake to cause damage. Now, what are they now here in short? In the amount of energy released is one of the factor. Amount of energy released. So it means if we have high amount of energy released, if the seismic wave is very strong, it means the energy released will also be high, and therefore the impact will also be very severe. So again, the depth of focus. Depth of focus. Depth of focus. Those of you who have been here, you know when we said about the focus, that this is the point where the earthquake originates inside the earth's surface. Now if we have shallow focus, if this is nearer the surface, it means the impact that will result from the earthquake will be very severe, and therefore a lot of people may lose life, structures dismantled, buildings collapsing down, and so forth. The other one being how solid the bedrock is. How solid the bedrock is. The bedrock is. What does this mean? If we mean that if the rock is very weak, like sand, sometimes it can undergo liquefaction, turning into solid, thereby causing a lot of impact to people, and so forth. And therefore, the damages of earthquake, as we have seen, are mainly controlled by this. If we have high energy, it means the impact will be very great. If we have the shallow focus, the impact also will be high to the earth's surface, depending on the nature of the bedrock and so forth. So, my dear student, having seen what how we are measuring the earthquake, we have seen the disasters or hazards caused by the earthquake, and what determines the amount of hazards that most likely will hit the Earth's surface. Our main issue is to assess now the impact of earthquakes. Okay, we have seen the impact of earthquake. It is not something so good. It is something that the geologists should deal with perpendicularly. And now, if these are the impacts most likely to face every being on the Earth's surface, every species on the Earth's surface, we have seen that even some parts of the surface may be overturned depending on the energy that has been released. Now, what are the precautions to minimize the impact of earthquake? Should we wait for the nature to prevail? Or we need to assess, we need to have the precautions. That if we don't take the precautions, death and injuries may be very high. Okay? All the systems we have on the surface, schools, hospitals, water pipes, gas pipes, communication lines may be dismantled by this. Now, what are the precautions to minimize the impact of earthquake? The first precaution that we need to do is building safer structures. Building safer structures. That even the building materials we use may be light to the extent that when the house has been dismantled by the earthquake, that deaths and injuries may not be so high. Let us stop using very heavy, complicated materials, blocks and so forth, that will be resistant to the Earth's surface. In case of the earthquake, the impact will be very great. The second, provision of education on earthquake safety. Education on earthquake safety. Safety. Now, people should be educated that Once you feel a shake wherever you are, what should you do? If you are in a car, do you have to remain in your car or you get out? If you are in tall buildings, where should you run to? Should you go to open places or where? So education should be provided so as to minimize the impact of earthquake. We need to prohibit explosive methods in mining. That the use of dynamites, the use of sophisticated machines should be avoided because they are dismantling the nature of the Earth's surface. So if we avoid this, we can reduce the impact of earthquake. Identification of hazardous areas. Identification of hazardous areas. What does this mean? Geological surveys should be made. Scientists should make research and identify the weak zones, the areas that are very prone to earthquake, so that even people who decide to live there may take precautions, that the houses that they build may be according to the nature of the area, that they need to use the very light materials, not heavy materials. So as in case of any earthquake, the damages may be very, very, very low. Sometimes we have this one that they should develop a local plan to face earthquake. Develop a local plan. A local plan to face earthquake. That in different localities now, there should be a plan. That in case, because no one is praying for earthquake, and these are tremors, that in case an earthquake takes place, locally, what should we do? What should people do so as to avoid the impact? So this should also be there as the means to reduce the impact of the earthquake. And also, remove heavy objects from high places. Heavy objects from high places. Imagine when the surface is shaking, you are somewhere with a steam tank, very huge one. If it shakes, it means it will drop out, okay? So it means let us try to remove these heavy materials, heavy objects from tall structures, that in case of this, it may not fall and kill people, okay? And else we should do is on this, these are generally the issues that we need to do as precautionary measures. There are a few of them that please our buildings should put up with the situation that in case we experience this severe shaking of the Earth's surface, the impacts may not be severe, may not lead to death and some other things. My dear student, as you visit the syllabus requirement, that on this we are to discuss the impact of earthquake, defining earthquake, focus, epicenter, assessing how the earthquake can be measured, plus what we have seen at last, that we need to have the impacts of the earthquake and to have some precautionary measures that in case of earthquake, what has to be done, what has to be taken as our first priority. That if the earth is shaking, you are indoor, what should we do? That we need to have the education on this, that we can move to safer places. My dear student, as we wind up this session, may I extend my sincere thanks to you for watching. Never plan to miss this interesting lesson of geography. Thank you. Welcome for the next session.